Hey, good morning. Thanks for coming to these sessions. Really appreciate. I know it's early morning. So what I'm hoping to do over the next 40-45 minutes is to kind of get you some insights around where the ML AI big data is trending, and then try to kind of match this trend with what we are doing as part of the Java platform group. We have a number of innovations, and see how those things can match, and hopefully kind of get a sense that at the end Java will play a significant place in the ML and AI space. So first, me, I am the vice president of engineering at Oracle. So I manage the engineering team that is producing the Java platform. Everything from VM library languages. Been there for some time. Came to Oracle through the Sun acquisitions, and then a while ago started in doing a little bit of at the time it was not called machine learning, but expert system in Prolog. First, the safe harbor statement, which means that whatever I'm going to say today, don't make purchase decisions on what I'm saying. And then I think I need to make another disclaimer, which is of course being part of the Java platform for many years, and I do have a bias on the Java technology. I think it's good. At the same time, I'm trying to be as objective as I can, but I need to acknowledge that. So you guys know where my team is. So what I want to cover is a quick survey on ML and AI libraries. There is a bunch of stuff already there, and you guys should be aware of what is there. Kind of go into some of the trends that I'm seeing around what I will call ML AI 2.0, something that in our industry is like the first wave, we build stuff, and then the second wave it is okay. Now we know what we need to build. Let's try to build them in the right way. And then looking at what we are doing in terms of upcoming platform features, and see how those features will apply to ML and AI problems. And then a quick summary. So starting around, if you look at that ML and AI, it's all about data. It's basically taking those massive amount of data and starting to make sense and extracting useful informations to make all kind of decisions. But at the end, it's starting with the data. And one of the very strong position that Java has in the big data space, it is that virtually, all the open source big data stack are either written in Java or have been written for the JVM. And that gives us and gives the Java platform these very unique positions as people start to expand what we are doing and what they want to do with big data and building all sorts of new algorithms, starting with platform that is already running in Java, give Java a significant advantage. As virtually every enterprise or organizations, public or private, is already running Java or is managing some JVM process. And then the Java platform has this enormous ecosystem in terms of third-party libraries, tool, and libraries that people can use to build all sorts of very interesting applications. Looking at some of the leading third-party libraries, there is Eclipse deep learning 4J. It's mostly widely used as for deep learnings. Something that compete very well with TensorFlow. In fact, those guys have done a good job around enabling the import of TensorFlow model into deep learning 4J. It's in production, solving all sort of problems, from cybersecurity, fraud detections, recommending system, kind of expert system that provide recommendations from a business point of view. And then image recognition, which is a place where a lot of the AI and machine learning have been fairly strong. Another system is Neurof. It's basic neural network that provide a bunch of layers around neural network computations. It's providing a lot of open capabilities in terms of processing and making decisions through neural network, and it's been used a lot in image recognitions. The Eclipse Arbitra project, again, run neural networks. How you train those neural networks, provide a bunch of optimizations using a number of standard neural network mathematical model like the Bayesian model. The ND4J libraries, which is in fact part of the deep learning 4J, it's really advanced and efficient n-dimensional arrays, because a lot of AI machine learning is around matrices multiplications, matrices operations. So and it's very well done in terms of providing some of the core operation that you expect you will need when you build your machine learning or AI algorithms. The Apache Open NLP, a significant area in AI and machine learning is around the abilities to do natural language processing, be able to recognize what is coming from a human or from a robot. It's supporting a bunch of different languages, doing standard parsing, semantic analysis, pitch tagging, to enable you to kind of process the information that's being done. Another natural language processing, which is just coming from Stanford, which is a core NLP, widely in use by a number of systems. It's a very advanced system, especially around the abilities to absorb and recognize multiple languages. There's a lot of different semantic between languages on how you are parsing and understanding a language, and those guys have done a tremendous job. And everything is in Java, which is in some way very exciting for me. Smile, it's providing a bunch of libraries that provide a lot of the mathematical foundations to building a lot of different sort of linear algebras, which is if you go back and look at a lot of the ML, it's all around linear algebra calculations, data parser, graph algorithms, which is also a place where we see more interest around scaling deep learning problems, natural language processing, and then another part that I believe is going to be very important moving forward is not just the raw computation, but be able also to visualize and getting immersive visualizations of all these data, so data scientists can make sense of what's happening. Rapid miners. So now we're getting into the place where it's more around data science of how a scientist will be able to analyze the data by tuning various parameters into the machine learning or AI models. They want to be able to see the effect, the impact, to figure out what is the best parameter setups. It's a full system that provide a lot of predictive machine learning capabilities. Also as well as some part of visualization, which I again think is going to be very important. Weka, it's another system that provide complete visualizations, a lot of support around classifications, regressions, and one of the nice things about the Weka, it is providing more standard kind of enterprise interactions via SQL. That's one of the big challenge, and something that will need to be addressed and is being addressed today. It is how you can access existing enterprise data that usually will reside in some kind of SQL database, and be able to import and manipulate and build AI and machine learning algorithms, extracting this data in a more efficient manners. A few more, the Apache Jena project, Tweedy, ECG23, and JGAP, which is around genetic algorithms. That's another space in AI where people study with neural network. Now they are moving into genetic algorithms, which have some very, very interesting characteristics around the abilities to morph and emerge through different changes as you are starting to do more calculations. So very interesting areas. And again, there is an explosion in terms of what the researchers and the industry is doing in terms of new algorithms. And that's kind of lead me in terms, from my hand, if I'm looking at this space, that's something that we have seen in the industry, many times, where there is early adopters, early innovators that build systems to kind of address their problems. And at some point, you see this morphing into, okay, now we need to basically move those technology into the enterprise. And also, as part of these transitions, typically, you're going to want to address and solve, bigger problems. You want to address those problems faster, because when you start to make, business decisions, the abilities to make those business decisions in, second minutes is becoming, way more important. Predictabilities. If I'm going to base my, enterprise business, on this technology, I need predictability. I mean, this stuff need to give me predictable responses to some level, and also, I need to have some level of robustness around the abilities to get what I need. Efficiency, that's a core of enterprise. Cost, that's, at some point people will look at it is, yeah, I want to run this model, I need all this hardware. That's very expensive, and people will do this trade-off, cost versus the ROI, which something that is important within the enterprise. And then so if you look at some of the trends here, the first one I will say is enterprise ubiquity, which is the technology need to be understood by the enterprise. Bringing new technology into the enterprise is a huge challenge because there is a lot to learn. And that gives Java and the JVM, huge advantage because, the enterprise knows Java, the enterprise knows the JVM, know how to deploy, manage the JVM. And so if there is a path where, you can bring, some of those machine learning AI technology running on the JVM, you are at a significant advantage. Maintainability is something that is important. It's no more around rewriting every 6 months what I have done. So you need some amount of stabilities. You need to have the abilities to maintain. Performance, efficiencies, scaling. We are looking around, terabyte, but soon will be in the petabytes. Visualizations, as I was mentioning. Service abilities, and then finally support. So I'm going to go through, all those items and kind of see and map them in terms of what we are doing, in terms of, the Java platform and the new features that we have, upcoming features that we have in our roadmap. So we do have, a number of projects in OpenJDK. As you guys know, all the work to advance the platform is being done in OpenJDK. There are a number of projects which I believe, are very relevant. And part of the thinking of the team, at Oracle is always to look at, a bit in the futures around what we expect our developers to need, in the upcoming years. So starting with, enterprise ubiquity, clearly, you want to easy access of the technology, and that's just, getting access to developer. I mean, and one of the things that Java has is that it's very easy to get Java developers. The cost of development is something that matters to enterprise. The cost to deploying the technology, the cost to maintain the technology is very important. And Java, with the large ecosystem, has a significant advantage here, and will continue to have a greater advantage, I believe, especially as you are moving those technology within the enterprise. Java and the JVM are the foundations of the cloud. Virtually every cloud on the planet, is built around Java or running the JVM. And that's a tremendous asset because you will have runtime that has been tuned and optimized to run in the cloud. Maintainabilities. So, and that's something that is very important because as the code size is growing and aging, the code maintainability is becoming a real matters. And I just put this cartoon here. I would say that, hey, the project I inherited was weak code. I need to rewrite it from scratch. How many of you have heard that before? Somebody coming in and say, hey, let's go and rewrite it. It's going to be better. It's going to be faster. Well, and the manager say, will there ever be an engineer? We say that the last guy who did a great job, so we don't have to rewrite everything. And of course, I'm hoping the idiot you hire to replace me will say that. And that kind of something that on one hand will enable the people that are maintaining the code to be more efficient. And that's an area where Java historically has been very strong. I truly believe that one of the reasons that Java has been so strong over the past 20 years is the core foundations, which is Java is all around readability. Make it easier for somebody that didn't write the code to be able to read the code and maintain it. And that's something is going to be very important as we move those large ML and AI services into the enterprise. The versatility of Java in terms of being able to address all sort of problems. So you don't have to go and jump to different technology to do what you need to do, and you can do that in Java. And then the last and not the least important, compatibilities. You guys know that we are spending tremendous amount of energy and effort to ensure compatibilities. Yes, as Mark said on the keynote, sometimes we have to break things, but we don't do that in purpose. We clearly understand that the compatibility is something that really matters. And that's something that, as you are moving those large and making all those large investments in ML and AI services, you're going to count on the fact that the technology you build those services on, when you upgrade to a new release, you don't have to rewrite everything. Performance or ultimate performance. Clearly, because of the type of computations, the size of the problem that need to be solved by ML and AI, performance is going to be a main factor. When you look at the technology. And so if we start around the programming languages, and I just took this benchmark from the Debian. Those guys are pretty neutrals. To give you a sense, comparing what people are doing right now in ML with Python versus what you could do in Java. And those numbers are order of magnitude in performance. And that's going to matter at some point, because when these things move within the enterprise, the bean counter, the accounting guys are going to say, hey, you guys need to be more efficient. As well as the business people are going to say, hey, I want this response not in a month or in hours. I want this response in a second. And just looking at the time, but also looking at the CPU utilizations, it's massive order of performance improvements, between the JVM and Python. And that's go for a lot of different benchmarks. Again, that's not my benchmark, but clearly, you guys should know that there are a significant performance gain, by using Java in the JVM. Density. As I was mentioning at the beginning, this big data world is around data, and the problems, are going to get bigger and bigger and bigger. And so the abilities for a technology and a runtime to ensure the most efficient, representation in data in the physical memory is going to be hugely important, and it usually factors in deciding, what technology is going to win at the end. We are embarked for, a few years in Project Valhalla or value type. The core of this project is to, provide this unification between, object and primitive type, and ensuring that you can get the best representations of a Java object in memory. Why this is important? It is important because you want to be able to manipulate the structures in a way that the structures are represented in a more efficient manners, in the physical memory of the system. And you don't have to look at that, I want to manipulate object, but I'm going to pay the price to represent an object as a class. In some case, I want to be able to represent this object as a class, but I want this object to work like an integer or a primitive. So as some of you may or may not know, there is a huge cost, in memory representations with Java object. Especially when you start to look at arrays of object, because every element in the array will contain pointer to this object, and so you have all those beautiful pointers, in directions. That was kind of the the place that was very in fashions in the 80s, and there is a lot of value around pointers, but this is extremely inefficient in terms of data representations. And so with value type, what we will basically introduce is a new representation for object of these unifications of primitive and object type. Well, now you can basically don't have to make the sacrifice of memory representations while still being able to use an object-oriented representation and manipulation of an object. Massive data scaling. Those ML problems are going to need, petabytes. And as you guys, may know already, the hardware vendors are going to push very hard. I mean, there are, new type of, memory subsystem that will enable us in the very, very near futures to have, petabyte system. And so we need, in terms of what we are doing with Java, we need to be able to support, and people that want to build ML and AI problems are going to search for runtime that can support such very large memory system, because at the end ML and AI is all around data. So we embarked a few years ago into a new garbage collectors, ZGC. ZGC is right now an experimental garbage collectors in JDK 11. The fundamental design of ZGC is all around scale. Be able to scale to extremely large, heap. Predictabilities, because at some point, yes, you want to be able to manage and operate on those very large heaps, but you want predictabilities. It doesn't make sense to have, a garbage collection that may take minutes to garbage collect, a terabyte, heap system. These garbage collections also, has, fundamental foundations that will help us to do more in this area of managing very, very large data sets. And then always there's been this trade-off around, you want predictabilities, you want large scale, you may have to pay for throughput. And so the aim of the project is really to minimize, the throughput, reductions. So the key foundations of this GC is that post time can increase with the heap size. We have to break, this linear or exponential, trend if we're going to be able to succeed here. And ML and AI, developers are going to look at technology that can help them, manage those massive amount of data in memory and managing them in a very, very efficient manner, knowing that, every 2 years they may have to double the size of the data sets. So ZGC introduced, a fundamental new way to, manage garbage collections, which is based on the notion of smart load barriers, and ensuring that everything is done in a concurrent manner. The fundamental, innovations here is to be able to, encode, part of the garbage collection information about the state of an object into the pointer itself. Why it is important is because now, the GC can just look at the pointers. We don't have to go and load the object in memory to be able to look at what is the state of the object. Just looking at the address itself, will be able to detect, was there a mutation in this object? And then this notion of coloring, the coloring will tell you the different state of the object in terms of the garbage collections, will enable the VM to be able to make the right decisions around, hey, this subject has not been modified, I can look at the color of the pointer, so I can go and proceed. Or if there is a change in the color of the pointers, then the VM can put back the subject into a consistent state. But we can do that as we are accessing the object, which is kind of reversing completely the GC model that we have had for many years. And those smart load barriers are going to be so important for the futures of Java and our abilities to support extremely large ML and AI services. And that's, I'm not seeing that on any of the runtime that is competitive to the Java platform. And the key intuitive idea here it is that in the 80s, we had heap around, a few megabytes, maybe a few gigabytes, and here kind of, the ratio of read and write, in terms of what the application is doing versus what the GC mutator threads, was doing, was kind of equivalence. But now when you look at that very, very large heap, the chance that you're going to collect an object that you're accessing is much less. So that's why that what we are doing now with ZGC is kind of optimizing for the most common case where there is no mutations in the object that you are accessing. Here is kind of, as I mentioned, ZGC is in JDK 11. Here is some benchmark from the spec in the GBB. The dark blue is a max GOPS, and the light blue is a critical GOPS. You know that in the spec GBB there is two measures. Max GOP is more around throughput. I don't care too much about latency of those transactions. I really want to get the maximum throughput. And the critical GOP is where there is a latency constraint, where you need to basically ensure that you can have this response time within the constraint to be able to get the mark here. So overall, you can see that with ZGC, we are not sacrificing throughput, which is something very novel in the space of low latency, high memory, garbage collectors. And then the big win is around critical GOPS, between 30% performance improvement. This is huge. But even more exciting is if you look at the post time. You can see that if you use the same scale, the post time are a few milliseconds. Yes, a few milliseconds. This is a game changer. These game changers that will enable people to build new kind of services that will get them, the predictabilities at high scale, which is something that I strongly believe is going to be critical for, addressing, upcoming ML and AI services problem. Performance, beyond small loads. You guys know that, that's it. We're kind of reaching the point where, CPU can scale. We have reached kind of the limit here. And the second thing it is, the vast majority of ML and AI problems are extremely well suited for GPU SIMD vector executions. So we started to embark on, a project to kind of refresh the way the JVM is interactive with the native system, with Project Panama, how we can, we are GNI, GNI is not the most approachable system as well as the most efficient system. And so we're kind of looking at enabling these interactions between the native operating system, the native hardware, and the JVM in a more approachable and much more efficient way. Part of this project also is kind of the conduit for enabling vector computing natively inside the JVM. And that's key capabilities that is essential to enable us to get the level of performance that data scientists are going to expect with ML and AI. There is a huge challenge here, how to represent vector operations into the JVM. How to ensure that we end up into this boxing and unboxing, which, as you know, would kill performance. We need to provide primitive specializations where when you build those vectors, you can ensure that at the end, through the value type and through Panama, you can get the most optimized representations in memory, in the GPU's memory, to get the maximum efficiencies. And then clearly from a programming model, we need to kind of understand at the end how we want to truly expose vector computing. The aim in the futures will be to be able to map lambda functions and be able to recognize, have the Java compiler, have the JVM recognized those lambda expressions, recognize that they are well formed, that they are a good target to be executed on the GPUs, and be able to do that automatically. But that's a long march here. And so the first step that we took was to look at around exposing a vector API, which is more explicit parallelism, but something that will get us a long way into this march toward full support for GPUs. So we want to introduce an API that is has enough expressibilities as well as portabilities. I mean, there are GPUs and SIMDs have on the hardware side have a lot of different nuance. So we want to make sure that the APIs that we are building will be generic enough that we can target all kinds of GPU system. Clearly, performance at the end, those systems, the implementation need to be extremely performant. And then we want to have also this graceful degradation. I mean, what you see in a lot of GPU computing, it is everything gets well until there is a side effect in the pipeline gets stored, and then your performance go down. And so we need to kind of understand how to manage those cliffs of performance when we push computations into the GPUs. I'm certainly very pleased with the support that we are getting from hardware vendors. Intel is really helping us with the design of those APIs, and that's something that we are now getting also interest from ARM and other vendors. So that's good that we get industry consortiums to kind of help make sure that we build the right abstractions for the JVM. And so kind of the ideas will be to reach a point in the near futures when we deliver Panama to enable you to get new type of objects that are vector objects, have the Java compilers produced internal bytecode representations of those vector operations. Our C2 compilers be able to take full advantage and generate GPU codes. And we now have part of the system in place for some hardwares. There is more work that needs to be done, but I think that's a place where we feel I feel very comfortable with the progress that we have made. Another area of performance is asynchronous computing and full throughput. I mean, those machine learning AI system will be bombarded by query from all sorts, and so we need to build in place a throughput system that's scale. So here again, we have embarked in another project, Project Loom, which is looking at introduced lightweight threads inside the JVM and the Java platform. We know for a long time that the language runtime are much better in a positioning to manage and schedule application thread, because we know what the computations and how to interleave. If you're putting a method into an asynchronous because you're waiting for an I/O, the JVM knows that, and we can take advantage to be able to schedule or unschedule these threads. The problem that we have right now is this blocking call model, where and you can see that in a number of large deployments, cloud deployments of Java, that the problem that Java has is less around taking advantage of the CPU, is a memory problem. The fact that the thread context that are megabytes inside are kind of limiting the number of threads that you can process or transactions you can process on a single system. So Project Loom, will introduce, lightweight threads that will be order of magnitude, cheaper in terms of memory representations, and that will enable you to, have millions and millions of fibers, in a system. Order of magnitude, improvements that is critical for, will be critical for many, ML and AI problems. And again here, the scale that we are talking are order of magnitude of what you have today. And today, in terms of high-end scale, Java and the JVM are the best runtime. This is why, virtually, every, planetary cloud services are using the JVM or Java as a runtime. So think in terms of, up leapfrogging ever where we are today, where other runtime, are still trying to catch up, where we are. So a tremendous advantage that the JVM and the Java platform will have in comparison to other technology. Another area which is not least important is visualizations, immersive visualizations. Yes, you're going to get all this data, but at the end, you're going to need to have the abilities to visualize this data. One thing that Java has is JavaFX. It's been a significant amount of work, over the years around JavaFX, and ensuring that, the rendering capabilities of JavaFX are extremely performant. As an example, there is some work that is done at NASA in their Deep Space Trajectory Explorer. So these visualizations show you basically the gravitational field as a space vehicle is approaching a planet where there's a lot of gravitational forces. Now the interesting part here, this is the type of problem that require the most compute intensive. And here you can see pretty much in real time the abilities of JavaFX and the JVM and Java to be able to sustain that level of computation and visualizations. All those gravitational fields are extremely complex and demand a lot of computations. So that's a huge asset that the Java platform will have, because at the end, I expect data scientists to want to have all these immersive visualizations to make sense of all this data. If I compare that with TensorFlow, which is kind of one of the most in vogue machine learning runtime, here is a TensorFlow board, which is kind of one visualization for TensorFlow. So here is another visualization that tried to visualize a data set and try to find unique patterns into these data sets. And the interesting part it is that, and you will see that you can manipulate the data, you see some level of scaling, but when you start to want to do a more complex computations, you're going to run into this problem with large problem. It's because the runtime of the Python runtime can sustain that high level of computations. And that's another key advantage that the Java platform will have against those technologies. Profiling, large problem, a lot of data. It's going to be critical that we have all the right set of tools to be able to instrument what is being done. One thing that we have is the Java Fly recorders. It's providing extremely low performance overhead. It's now in JDK 11. It used to be a commercial feature that we have open source in JDK 11. The key part here that you have to understand is that JF4 is built deep inside the JVM. So instead of having, and what people have done since they don't have the control of the JVM, we are the only one that have control of the JVM. We know when to collect information. So if you have to collect information outside of the JVM, you have in some case have to duplicate what we are doing, or you don't know when to collect informations. There are very precise point during the execution of your applications where the VM know that I'm going to stop the application thread, so now I can go and collect information. And I can collect this information with the lowest overhead possible. And that's why that with JF4, we can get up to less than a few % performance degradations for profiling in productions at large scale. And That's something that is extremely useful for enterprise, to be able to get all this level of introspections. Finally, support. Enterprise, guess what? They're going to demand support, because if I'm building service, whether service or mission critical to running my business, I want to be able to call somebody to address these issues. And I know in a lot of places always this saying, oh yeah, I can do it, I can do that by myself. But this is very hard. This is very hard. And so we are very pleased to introduce a new Java SE subscriptions. And why get support from Oracle? Because we are the steward of this technology. We have unparalleled expertise across all the area of the platform, from the JVM language libraries, you name it. Trying to support that on your own, and it's going to be because you don't know where you're going to run into a problem. And that's very, very difficult, I can tell you, to understand where those problems lay down. Why? Because if you look at the contributions on JDK 11, there is a significant contribution from our engineering team. So we are the expert in this area. If you're going to have your business rely on this technology, on those machine learning, on those AI algorithms, you're going to want to have the right partner that can really provide you the right level of support. We introduced a new pricings, very affordable through subscriptions, $25 per processors at most. There is huge discount. If you go up to 1020, you're getting a 50% discount. $12.50. And basically the idea is you pay as you use. You don't have to go and pay more. If you need more, you get more subscriptions. It's a monthly subscription. Okay, so in summary, there is a growing ecosystem around ML and AI in Java. I strongly believe that we have these unique opportunities to position Java and the JVM as a leading runtime for ML and AI 2.0. The open source big data stack, big data, is already in Java, so it's for us to kind of expand on what we are doing. The roadmap that we have in terms of the Java platform is very exciting. And so my call of action is come and help us have the right set of features, provide us feedback in terms of the feature that you believe we should be building in the platform to support ML and AI problem. Thank you. So we have 4 or 5 minutes for questions. Any questions? One, two, three. Thank you very much. Have a good one.